All right, today it's March 12th, and so when is the midterm due? Did I make, is the midterm due already, or is it due 14th? Yeah, right, so oh, yeah, okay, well, yeah, it's due, if you can't get it done by, if you can't get it done by, you know, whenever I said it was due, then we can meet during spring break if you need help. Huh? If you're already done, then that's great. So if it's handed in, I can start grading them if you want. I can't remember. I get this class and then the other class mixed up sometimes. The midterm in the other class was like way harder than I thought it was going to be. This one shouldn't be so hard. Anyway, so I guess today I'd like to go through the slides for chapter 7, which is arrays. Start covering arrays. So let me switch over to the screen. And so let's do this, and let's just plug through this. Arrays and lists. All right, so we're going to learn about, well, I guess we're going to review value types and reference types, array basics, working with files and arrays, passing arrays as arguments to methods, some useful array algorithms like sorting, advanced algorithms for sorting and searching, two-dimensional arrays, jagged arrays, list collections. Value types and reference types. In C#, data types fall into, one way of categorizing them is value types or reference types. A variable that is used to hold a value is a value type of variable, and they actually hold data. Whereas variables can also hold a reference to a variable that holds data or reference to an object. Those are commonly called a reference variable. So you can have a variable called, v, and that can just refer to a place in memory that holds some value like 21 or something. Or, see, so this is a value type. This is a value type. Because V refers to an actual place in memory that stores an actual value. So if you change V to 42, and this thing here changes to 42, for example. Or you can have a reference variable, which we'll call R, and that points to, that would be something that actually is the address of a value type. So let's say that we have R, which is actually points to V, or let's say this actually points to V, and this is 21. So it's like you have one level of indirection. You can call it that. And so when you're passing R to somebody, to a method, let's say you're passing R to a method, you're actually passing a reference to V, and V it holds the actual value. So you might have some other variable here. You might have something else, X, and that's actually pointing to something else like 82 or something. So R could actually change and and point to X, and then so R basically refers to another variable that has a different value. This actually is not a very good way of explaining it. It works better. The reason we're talking about reference variables in this chapter is because when you pass an array to a method, you don't pass the whole big array, because the array can hold lots of different values. You're passing a reference to the array, and we'll see what that means more in a moment. So how a value type works. When you declare a value type variable, the compiler allocates a chunk of memory that is big enough to store the variable. The memory that is allocated for a value type variable is the actual location that will hold the value. Okay, so when you're working with a value type, you're using a variable that holds a piece of data. So like for example, when C# stores an integer, it takes up 32 bits or 4 bytes. Okay, it takes up 4 bytes of memory. So if you declare a variable v that's a value type, you're actually allocating 32 bits or 4 bytes to store an actual number. The value type of a variable actually holds the data. Whereas with a reference type, when you work with a reference type, you use 2 things. There's an object that is created in the memory, and then there's a variable that references the object. So the object that is created in the memory holds the data. The variable is then created to hold a value called a reference. The reference variable does not hold the actual data. It simply holds like the address of the data, or it simply refers to the data. A reference type links the variable that holds the actual data. So if a kite is an object, then the spool of string that holds the kite is the reference. So you can think of this as like something that holds a reference to the kite. That as opposed to actually holding the kite. Okay, so you have some variable, some value type that's actually holding the kite itself, but you can have a reference that's holding a reference variable R that's holding a reference to the kite. Now, what this means is that you can a reference variable could actually hold some other reference to some other kite. This is dumb. So there are 2 steps required to creating a reference type. First, you declare a reference variable, and then you create an object and associate it to the reference variable. So for example, we talked about random numbers or random classes in the last chapter, and the random rand part declares a variable named rand. And this new random part creates an object that returns a reference to the object. So this creates a variable called rand, and then this is a reference to, this part creates an object and returns a reference to the object. The equal operator assigns the reference that is returned from the new operator to the random variable. This is kind of confusing, I know, but it'll become more clear later. Once we start talking about arrays more, you know, we should actually talk about arrays first and then talk about these references and values, and you'll see why. An array allows you to store a group of items of the same data type together in memory. So processing a large number of items in an array is usually easier than processing a large number of items stored as separate variables. This is because each variable can hold only one piece of data. So here we have a single variable called number1, and that's storing a value 99. And we have a separate single variable called number2, and that's storing the value 100, for example. Each variable is a separate item that must be declared and individually processed. Variables are not ideal for storing and processing lists of data. Arrays are reference type objects. To create an array, you need to declare a reference type object, and then you need to declare the object and associate it with the reference variable. So in C#, the generic format to declare a reference variable for an array looks like this. So this is saying you're declaring a reference to an array. This data type can be like int. It looks like this. You're declaring a reference to an integer array called array name. Call it array int or something. So this, for example, declares a reference to an integer array. And this is like sort of a thing that says that it's an array. The generic format to create the array object and associate with a variable looks like this. So, so once we've created an array name, like this, then we can say this is a reference to, and this is the actual array. This allocates the space out there in the memory. It's going to create this amount of space. And this is a reference. It's usually probably the memory address of the first one. So this is like the memory address of the first one, and that's going to be stored in here. The new keyword creates an object in memory. So this is what creates the object. It also returns a reference to that array. So for example, you know, you have this this variable called numbers array, and that's a variable. And then you have this int 6. So that means you've got, you know, 1, 2, 3, 4, 5, 6. So you've got this thing in memory, 1, 2, 3, 4, 5, 6. So this is memory. This is in the memory, and it's going to be contiguous locations. So if we're talking about actual addressing memory, if this is like, and let's say it's integers, and memory is addressed in bytes. So let's say this is location 100 right here. This is going to be location 104. This will be location 108. This will be location 112, 116, and 120, let's say. So these are actually locations in memory. The reason they're 4 apart because memory is addressed by bytes, and it's 4 bytes to an integer. So it could be like this. And the numbers array, this is the numbers array variable. It's going to be 100 because it's a reference to the first one. So numbers array, this thing is going to be equal to 100. So you can see that in this case, numbers array is a reference to the actual array of numbers. Whereas if it were a value type, then numbers array would actually equal the value, would actually equal some number like the value 100 or something. You see, so there's kind of like this indirection thing here where this is a reference type, so it actually holds the address of something. Now here, this is an array of 6 integers. It wouldn't have to be an array of 6 integers. It could be just a plain old integer, okay? And you can still have this indirect reference, or this reference to it. So it's there. You'd have numbers array would be value 100, and 100 is actually an address pointing over here, and this can be something else, like 55 or something, some value 55 or something. So numbers array does not equal 55. It references a variable that contains the value 55. Okay, in the previous example, there are 2 statements. This is actually saying that numbers array, this variable name, is a reference variable. It references an integer array. Okay, so this declares it as a reference variable, and this actually assigns the value. This creates a new integer array out there in memory someplace, wherever it ends up being. In this example, I said it was going to start at location 100, but it could start at location anywhere, and it's going to be 6 of them, and it'll no doubt be 6 contiguous locations in memory, just to make it easier. And it's a new one, and it's going to return a reference. So it's going to be the address of the first one, and that's what's going to go in here, the address of the first one. So, you can combine the 2 statements and have it look like that. Make it easier. So you can create arrays of any data type. So here you might have an array of 100 temperatures. The variables are double type variables, which means there can be a decimal point. Here you might have an array of 50 prices. Here you might have an array of 1,200 strings. And it could be like an array of names, array of prices, and an array of temperatures. An array's size declarator must be a positive integer and can be a literal value. So here, for example, we're defining a constant. The constant is called size, and the value is 6. And here we're declaring an integer array of size 6, and this is going to be a reference to it. And here we're declaring a reference variable called numbers array, and it references an integer array, and this is going to store the location of the first array element in this variable here. So just as an aside, the size of this array here, the size of this variable is going to be a size that is big enough to be able to uniquely identify a memory location. Okay, well, it's going to probably be bigger than 4 bytes because 4 bytes, you probably have more memory than whatever 4 bytes is. What's that, like 16 million or something? 2 to the 32 power is like 16 million or so. You're going to have more than 16 million bytes in memory. You're going to have gigabytes of memory. So the size of this variable is going to be big enough to hold an address. It's going to be big enough to hold a RAM address. It only needs to be 1 RAM address, so it needs just the first one, the first one of this array. This array can be huge. It can be like, 1 million integers or something. And this only has to store the address of the first one. It is a preferred practice to use a named constant as the size declarator. Okay, so it's a preferred practice to first declare a constant and then use that constant to declare the size of the array. The storage locations in an array are known as the elements. In memory, an array's elements are located in consecutive memory locations. That makes them easier to address. If you're going to loop through and start with the first one, you're going to loop and go down through them. It helps if they're in consecutive memory locations, because then to get to the next one is just the same distance and so on. Each element in an array is assigned a unique number known as a subscript. Subscripts are used to identify specific elements in an array, starting with 0. The element the first element has subscript 0, and the last element has subscript n-1. It's got n elements. So this is kind of what it looks like, what I've been drawing. So we have this numbers array variable, and this you can say it points. It points to this array here, which is a 1, 2, 3, 4, 5. It's a 5-element array, and this thing here is going to be someplace in memory. Who knows where? It's going to be someplace in the RAM memory, wherever the compiler or the loader allocates that space for it. There's going to be a bunch of programs. There's going to be program. There's going to be the program memory, and there's going to be the data memory, and there could be, in a computer like this, there's a bunch of different programs running at the same time, operating system programs and all this and that, and it's going to be allocated somewhere, and wherever this is allocated, the first one, the address of the first one is going to be right in here. When you create a numeric array in C#, its elements are set to the value 0 by default. So when you create a new instance of an array, when you create a new array like this, they're going to start out all being 0. I don't think that's such a good idea, but that's the way it is. Given the following code, you can access each individual element using their subscript. So let's say you declare an array, or no, let's say you declare a constant. The constant is called size, and the value of size is 5. And then you create this array, this new array that's going to have 5 integer. Well, now why did they use a 5 here? They should have, this should be S-I-Z-E. Silly stupidness. Should be that. So we declare a new integer array that's 5 elements, and we're going to refer to that array using this word here, numbers array. Wait a second. This should be int errors. Should be like that. This is not a good. It should be like this. Oh, I can't even change this, can I? Oh well. Well, you know what I mean. This should have a square bracket here, and the word 5 should be S-I-Z-E. Anyway, so you can refer to, and what this is doing is it's assigning the first one equal to the value 20, and the second one equal to the value 20, and the third one equal to the value 20, fourth, and the fifth one. And so, for example, if we're going to refer to the third element, we refer to it this way. You can create an array. You can optionally initialize it with a group of values. So you can do it this way. Now this is more like it. Okay, it's you do this. It's got the word size in here instead of 5. It's got these brackets here. That's how it should be. And this is assigning it 10, 20, 30, 40, 50. I bet you this was supposed to be 10, 20, 30, 40, 50. or simply this. So here, we aren't actually specifying the integer array is going to be size 5. We just throw in 5 values here, you know, inside these curly braces, and that defines it that way. Or you can even do it this way. Here you're saying that you're going to declare an integer array called numbers array, and it's going to have these integers in them. And the system is smart enough to know that, oh, there's 5 of them. Okay, so really they mean this. Really they mean this. They all produce the same results. And so you can use loops like this. Arrays commonly use an integer as a subscript. You can then create a loop and step through the array. For example, here we're declaring a constant called size, and it's going to be 3. So there's going to be 3 elements of this array. We're declaring a new array. We're going to reference it by using my values as the name of it. It's an integer array. It's referencing an integer array, and this is actually declaring it. It's going to be 3 elements in it. Here we're going to loop through index, the variable index 0, 1, and 2. 0, 1, and 2. And so this is going to assign those 3 elements equal to the value 99. And you notice that the number of iterations cannot exceed the array size. Otherwise, an exception will be thrown at runtime. So this would cause an exception because this is going to go 0 to 3. And you don't want to go 0 to 3. You want to go 0 to 2. Because if you go 0 to 3, that's 4 elements. 0, 1, 2, 3. That's 4. And you've only declared it as 3. So the length property is the number of elements in the array. So here in this array we've declared temperatures, and it's going to be 25 double variables, double values. And so the length of temperatures is 25. The length property can be useful when processing the entire array. You can do this. That way, you don't have to remember what you declared it as. You don't have to use a constant. You don't have to use an actual value. You can just say whatever it is. For each is another way of referring to arrays. We haven't, when I was creating the midterm, I first created it using a for each loop. But then I realized that we don't cover for each loops until chapter 7. So but for each is easier if you're going to loop through a list, and we have a list box, and the list box has names in it, right? So it makes kind of makes more sense to do for each name in the list box, and it just starts at the top and goes down. Instead, we hadn't covered for each yet, so I had to use the indexing thing, and that's where I used selected index. Started out by setting selected index equal to 0, and then looping up through the length of the list box. But anyway, for each is like a for loop. It's like this, like a for loop, except for we sort of do away with the indexing, and we just we declare a variable name, and so this is like this is a type. So let's say it's a string array. This would be for each string some name in the array of strings, and as this thing loops, it loops through every element in the array, and you refer to that particular element at that particular loop, at that particular iteration with this. So the for each loop is designed to work with a temporary read-only variable known as the iteration variable. The generic format looks like this. So here, for example, let's say we declare an array of, and we're going to call it numbers. And it's, what happened to my watch? And the values is going to be 3, 6, and 9. This is how we loop through that. We're going to loop through numbers. And the first iteration, val is going to be equal to the first one. The second time we go through the loop, val is going to be equal to the second one. The third time we go through the loop, val is going to be equal to 9. So first it's going to display out 3, then it's going to display out 6, then it's going to display out 9 in this loop here. So that's how for each works. So we don't have to have, so we don't have to have an index. We aren't referring to we aren't referring to numbers. You know, 0 for the first one, 1 for the second one, 2 for the third one. We aren't doing that. Or we don't have some integer I, where we have to say numbers I, numbers I. We don't have to do that. We don't have to have subscripts. We can just do it this way. No subscripts. Normally, you'd have to use subscripts to refer to each individual element. You'd have to use a subscript like this. But when you use for each like this, you don't have to. Working with files and an array. The book demonstrates how to write an array's contents to a file. So we have code like this, where we have, let's declare an array of integers. We're going to call this array numbers, and we're going to assign 10 to the first element, 20 to the second, 30 to the third, 40 to the fourth, and 50 to the fifth element. And then we're going to declare a stream writer object. We're going to name it output file. And we're going to connect output file, this output file variable, we're going to connect that to an actual file. It's going to be a file that we're going to write to. And the name of the file is going to be values.txt. And then we're going to loop through. We're going to do for, and this time we're using the regular for, where we have an index. We have a subscript. We're looping through. This index is going to start out with 0, 1, 2, 3, 4 for the elements. And so we're going to loop through index going from 0 to 4. Each time we're going to increment by 1, and each time we're going to write out whatever the value is. So we don't have to change it. So I guess we don't need to put a toString. Maybe we should put a toString here or something. toString, I'm not sure. This might work. Probably will work. Reading values from an array. Here we're gonna here we gotta change it to a number. Okay, so here we're defining a constant called size, and it's going to have the value 5. And then we're going to declare an integer array that's got 5 elements in it. And we're going to refer to that integer array using the word numbers. So we're going to call this array numbers. It's going to have 5 elements. We're going to start out with an integer value index. We're going to start out equal to 0. We're going to create a stream reader object called input file. We're going to connect input file, this variable name. We're going to connect that to an actual file called values.txt. And we're going to open it up to read, start from the beginning. And then we're going to loop, and while index is less than 5, and we haven't hit the end of the input file yet, while that's true, we're going to read it in. We're going to parse it into an integer, and we're going to save it into this this position, the numbers position referred to by index, starting with 0, 0, 1, 2, 3, 4. Each time we're going to increment the index by 1, and when we're done, we're going to close it. Here we're doing a string. So here we have passing an array as an argument. An entire array can be passed as one argument to a method. So here we've declared a new array, a string array. We're going to call it people. And we're going to initialize people with four names: Bill, Jill, Phil, and Will. And we're going to create a method down here. This is a method that we've written. And the method is called showArray. And it takes as a parameter, it takes a string array as a parameter. And here we loop through all of the values in that array. See, we don't need to know any index or anything. We're just going to loop through them all. And each time we're going to display out the next name. And we're going to refer to it as str. So the first time this goes through, str is going to be the first one, which will be Bill. Next time it'll be the next one, which is Jill, Phil, and Will. And this is how we call the method. Now, this is where it helps to learn helps to know what passing by reference. So when we pass this argument, this is an array that we're passing. We are not passing the entire array down to this method. We're only passing the reference to the array down to this method. So if down here, let's say we had this, and then the next time we had str array. This is a bad example because we can't reference it back. Let's say, okay, well, it's possible we cannot do it here. Wait a minute. Let's say instead of a for each loop, we used a for. Let's say it's for. Let me erase this. Okay, let's say instead of this we had for. Let's say we had for I equals 0. I is less than str array dot length. Then we had that, I plus plus. Let's say we had that, and then down here we had instead of str we had str array I. Okay, so instead of using a for each, we're just using a for, and we have that instead. Okay, so in this example that I've just created, we are referencing each element of the array by an index. What we could do then down here, right here, we could say str array I equals, I don't know, Fred or something. Okay, so let's say after we display out the element, let's say we set it equal to Fred. Then when we come back out here again, then when the method's done, all of the value of peoples is different, because down here we actually changed it. The reason we can change it is because when we pass it, we're passing a reference to the array. We're not passing the array itself. If we were passing the array itself, we wouldn't be able to do this, because this would be different. You know, we'd be referring to a different set of memory locations. Here it can also be passed individually, and here we're actually we've created this is a different method where we actually display one person at a time, like this. Here we aren't passing an array, we're actually passing the value itself. So here we're passing the value itself down to show people. And so if we change str down here, it does not change it back out here again. So that's the difference between passing by value and passing by reference. Here's sequential search. Okay, here's some useful array algorithms. Sequential search. Sequential search uses a loop to sequentially step through an array, starting with the first element. For example, okay, so here we're looking for we are looking to see if okay, in this example, we are looking to find we are going to look through all the elements in this array to see if we can find the index of the array element that equals value. So let's say we're talking about this array here, and let's say we're looking to see if 40 is in the array. Okay, let's say we're looking to see if the 40 is in the array. And what we want to know is the index of 40. By the way, the index of 40 is 3, right? 0, 1, 2, 3. The index of 40 is 3. So in this here, if we're using this as an example, we are trying to find the index of 40. So what this does is this loops through, it looks at every single one of them, starts out with index 0, checks to see if index 0 is 40. If it is, it says we found it, and we pass back what it is. If it isn't, then we skip over this part and we just go start again, index +1. And we're either going to find it or we're not. If we don't find it, we go all the way to the end and we go past, we're done, and we found is never found is still equal to false, and we say not found. Or we find it, and then this loop will end as soon as we find it, because index will be found, and then we'll say found is true, and then we'll be able to pass back what the index is. So this is a sequential search. A sequential search, the worst case is you have to look at every single one of them. And if you don't find it, you look at every single one of them. This code searches a string array for a special value. If the value is found, the position is returned. Otherwise, -1 is returned. This algorithm is not efficient. Copying an array. To create a second array and copy the individual element of the source array to the target array. So this is a useful algorithm if you want to copy an array from one position to another. You cannot just say array 1 is equal to array 2. You can't do that. You got to go each individual one. You got to say, you got to declare array 2, and then you got to loop through each element of the first array one by one and set the second array equal to the first array, element by element. Comparing is the same kind of thing. If you want to compare, you got to compare each one, and you keep on looping. You keep on looping as long as the two elements are equal. Once it's not equal, then it's not. Then you've determined the whole array is not equal, and then you can return a false. So here's totaling up the value of an array. You can use in a loop. You can use a loop. You declare a variable total. Start out total equals 0. Some value int or something. And then you loop each time you add whatever it is to total, and then when you're done, you have the value. You have the total value, and then if you want to find the average, you divide it by the number of units, or divide it by the length of the array that you're totaling. Finding the highest value in an array, this is a pretty important thing to know how to do, finding the highest and the lowest. You create a value. You create a value to hold the highest value found. You start with assuming the element 0 is the highest, so you start by setting highest to a really low element. And then you step through one by one, and if you find that the element that you're looking at is bigger than what you have stored as the highest value, then you set that highest value equal to that element. So when the loop is done, the highest value is found. So here's how you do it. Let's say you have an array of numbers, looks like this. And that's right, you don't need to set it to a very low value, you can just set it to the first value. So here we have an array of numbers, and it's just some random array of numbers. And then we're going to set the highest value equal to the first one. And then we loop through the rest of them, and so we don't have to start with 0, we can start with 1. We loop through the rest of them. Yeah, this is similar to the midterm, isn't it? You set you don't need to start with the 0th element. You can start with the first one, and each time you check if this one we're looking at is bigger than what we have stored as the highest value. If it is bigger than what we've stored as the highest value, then we've discovered a new high. So we set highest equal to that new high. So the first time, highest is going to equal 8. And so then we're going to see if 1 is bigger than 8. It's not. So it's going to skip out. Then we're going to see if 12 is bigger than 8. 12 is bigger than 8. So we have 12 is bigger than 8. And so this is going to set highest now is equal to 12. 12 is bigger than 8. So now highest is equal to 12. And then we're going to check 6. Is 6 bigger than 12? No, it's not. Is 2 bigger than 12? No, it's not. Dot, 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 until we're done. Same with the lowest. Same algorithm, except for instead of greater than, it's less than. We set it equal to the first one, and we just loop. Is 1 less than 8? Yes, it is. So now we have a new low. Is 12 less than 1? No, it's not. Is 6 less than 1? No, it's not. Is 2 less than 1? No, it's not. Dot, dot, dot. In the end, we'll have the lowest value. So these are standard algorithms that you learn in this class, in your first programming class, and you're going to use these algorithms lots of times in the future. Okay, here we're talking about sorting. Selection sort. There's several different kinds of sorting methods. There's 10 different kinds of sorting methods. And each sorting method works better depending on the data. Some sorting methods work really well if the data is almost sorted, and other sorting methods, it doesn't matter how the data is. And some sorting methods are called stable sorts, which means if you've got elements in there that are the same, then when you're done sorting, they're going to remain in the same order that they were originally. Whereas an unstable sort, it's you can't guarantee that. Some sorting methods take longer than others. Take more time than others. So the way a selection sort works, that's one kind of sort. You go through and you locate the smallest value and you move it into element 0. And then you go through and you locate the second smallest value and you move it to element number 1. And you keep on doing it until you've gone through all of them. So you probably will exchange these because you have to do something with the. So you go through, you find the smallest value, and you move it to element 0. There is something in element 0 to begin with, and you probably move that to where the smallest value came from. So there would be an exchange going on because you have to have some place to put it. Or you might create another array, and you, like what we did in our midterm, we actually created a second array. So in a sense, your midterm did kind of like a selection sort, because first it found the smallest element, but we had 2 temporary arrays that we used to temporarily store the intermediate states of the arrays. That's selection sort. Advanced sorting algorithms for searching and sorting. This algorithm requires swapping array. Okay, so this is how we do swap. Okay, here's a swap function. We use these swap functions a lot. When you're swapping, you need a temporary location. So this swaps A and B. It takes A, puts it where B was, B puts it where A was. So you declare a temporary variable, you store A into the temporary variable, and then you put B into A, and then you put the contents of the temporary variable into B. That ends up swapping it. Oh, here's a selection sort. Okay, yeah, here's how we do it. We start out, and these sort algorithms usually have a loop inside of a loop. It's a loop inside of the loop. So we've got an outer loop, we've got an inner loop. And so we start out with start scan is going to be equal to 0. And we say we have these temporary variables here. We've got min index and min value. And here we're going to keep track of the minimum value. So we're going to loop through, find the minimum value, and remember where that is, and then we're going to exchange it. And we're first going to find the value that goes into the 0th element, then we're going to find the value that goes into the first element, and second element, and so on. So we're going to start out by at the top of the array, the minimum index is going to be 0 because that start scan is at 0, and the minimum value is equal to I array. it's I array min index. Boy, these slides are so bad. So the minimum index is 0. The minimum value is going to be whatever's at the 0, was ever at 0. And then we're going to start looping. And we're going to go starting from the next one all the way up to the top, and we're going to keep track, and we're going to find the smallest value. So this is the same algorithm we use to find the smallest value. So we're going to loop through, and each time if we encounter an array element that's less than this minimum value, and we're going to remember it. We're going to remember what the value is, and we're going to remember what the position of the value, what the position was. And when we're all done with this loop, we will have the smallest value that's in the array and the position of it. And then we're going to swap them. So this should be start scan. We're going to swap them. So now in the 0th element will be the smallest element. And then, so we've got the smallest element in the first position. And then we're going to go to the next one. See, this outer loop starts, goes from the 0th one and the first one, second, third, fourth. So this outer one is always going to find the next smallest element. And this inner loop here starts at the next one just above it. So if you think about this for a while, you can see that it works. All right, so that's selection sort. Binary search. Okay, we looked at sequential search. The trouble with sequential search is, worst case, you have to look at every single element. Best case is the first one you look at is the one you're looking for. Worst case is that it's not in there at all. If it's not in there at all, you got to look at every single element to find out it's not in there at all. Well, binary search is different. The thing about binary search is you have to start with a sorted array. Okay, and so what you do is you have this sorted array, and it's this from smallest to biggest. And so what you can do is you can start. The first thing you do is you look in exactly the middle, and if the one that you're looking at exactly in the middle is bigger than what you're looking for, then you know that if the one you're looking for is in there, it's going to be above it, or it's going to be before it. If the one in the middle is smaller than what you're looking for, then you know that if it's in there, it's going to come afterwards. And so by looking at one thing, you are able to exclude half the array. Okay, so then so after the first one, you know that you're either going to look at just the top half or just the bottom half. And then you do the same thing. You cut that one in half. And so each time you look, you're actually cutting the number of elements that you have to look at in half. So if you start out with 1,000 elements and you're looking for a number, you start by looking at the 500th one. And if the one you're looking for is smaller, then you've automatically eliminated 501 to 1,000. And all you have to do is look at 0 to 500. And then you cut that in half, and then you've cut out 250 of them. So each time you cut it in half, 1,000, 500, 250, 125, 62, 32. 62, 31. And so it ends up being the square root of, no, it ends up being the log to the base 2 of the number of elements. So so it's easier to think of them, to think of the numbers as powers of 2. So if you start out with 1024, you start out with 1024 elements, that's 2 to the 10th power, because it's 1024, 512, 256, 128, 64, 32, 16, 8, 4, 2, 1. Okay, so anyway, that's 10. And so if it's a really big number, like 2 to the 32nd power is 16 million something. If you have 16 million, you know you only have to look 32 times at most before you find out if it's in there or not. So you can see that with a binary search algorithm, it's going to be way more efficient than a sequential search algorithm. And so it's almost always worth it to sort the thing first and then do your search. Although sometimes sorting can take longer. Sorting is and the amount of time that these algorithms take, it's called the computational complexity of these algorithms. We in most programming, in the programming that we do, we don't really ever need to analyze algorithms, analyze the computational complexity of algorithms. We basically just learn the best ones. But if you're going to go and be a theoretical computer scientist, then you spend a lot of time analyzing the computational complexity of algorithms. Because if you can come up with some new algorithm that's slightly better performing than some previously well-known algorithm, then you become famous. But the thing is lately, I'd say in the last 20 or 30 years, there hasn't been much new stuff. It's like when these algorithms first came out, when computers first became practical in the 60s and the 70s. There was a flurry of research, and they solved a lot of these problems, and they found that I think the last time they came up with a faster sorting algorithm was probably in the 80s or something. They came out with a faster sorting algorithm, but since then there hasn't been much. So we're at a good time now where all the theoretical stuff has been figured out, and now we learn the best. We learn the best ways, and also computer languages today are smart enough to look at your data and recognize and figure out what the best sorting algorithm is. Okay, it didn't used to be that way. All right, so we're done with the class today. So next time we'll continue with two-dimensional arrays and jagged arrays. All right. So if you have any last-minute questions on the midterm, ask me on Thursday. All right. Any more questions? All right. Thanks for watching.